so I just burnt my tongue. Hi, my name is Sebastian Palacios, and today I'm gonna be solving another one of my problems, which is drinking tea. It is too hot for me to drink it. That's the problem. How do I solve this? To know how hot is the tea. How do I do this? With a thermistor. What the thermistor does is that whenever it receives heat or temperature in general, it reacts with doing a resistance, and whenever it is too hot, then it's gonna be less resisting. Less resisting, and therefore it's gonna be easier for the voltage to flow through it. So we're gonna be using this.
The logic conditions for this project are pretty straightforward. First, read the temperature in Celsius. If the temperature is less than 55 Celsius, then the LED that is blue will turn on. If not, read again. If it is between 55 and 60 Celsius, the green LED will turn on. If not, if it is over 60 Celsius, then the red LED will turn on.
The materials we'll be needing for this project are these 3 LEDs, green, blue, and red, the thermistor, a 10K ohm resistor, a bunch of jumper cables, Arduino, 9-volt battery, a breadboard, and this thing that I'm gonna be using to stand up the breadboard and everything together. Oh yeah, and some tape. How the system works is, first the current goes from the 5-volt up there and to the thermistor. The thermistor will continue its path down and split into 2 parts. One that is going to the ground with the 10K ohm resistor, and the other one that goes to the analog input A0. This is the one that's gonna be detecting the value that the thermistor is gonna be outputting. The other is the D10, D9, and D8 ports. These are gonna be delivering power to the LEDs, the green, the blue, and the red. Each of them are also connected to the ground directly, without passing through the 10K ohm resistance.
But how do we extract the temperature from the resistance in the thermistor? The only data that is obtained from the resistor is discrete memory, coming from the analog input. When all of the 5 volts are received, the value will be 123. When there is none, it will be 0. But this is for the whole system. The only thing that needs to be calculated is the resistance of one of these 2 resistors, the one from the thermistor. So the voltage divider formula is then used to isolate the resistance from the thermistor. With the resistance now obtained to half the Kelvin, we're gonna be using a conversion using C1, C2, and C3. These are parameters that are used to define the curve the thermistor does when it receives heat, as it is not directly proportional to the resistance it provides. It uses logarithms to measure this exponential change. Now the only thing left is to convert the Kelvin into Celsius. Pretty easy, just subtracting 273.15 and it is completed.
To build the Arduino system, we're gonna be first using the Arduino, the breadboard, and we're gonna be placing them over the table. First, we connect the positive 5-volt to the side of the breadboard, then the ground to the other side of the breadboard. The next thing is this jumper cable that goes to the middle. Next, the thermistor. I'm gonna be connecting to one of the rows of the breadboard and to the other one. Then the cable that connects to the A0 analog port and the 10 kilo ohm resistor. Everything does a closed circuit with the negative ground cable. Next comes the LEDs. First the red one, then the green one, and then the blue one. connecting their negative parts to the negative side of the breadboard. Then the cable connecting the 10 to the red LED, the white one connecting to the green LED, and the 8 connecting to the blue one. Now it is finished and we have to join them together so it can be a whole part. Then joining them together with the tape. As you can see, I'm using this black tape. Any tape can work. And then connecting the Arduino to the back side of the breadboard. The next thing is to join this metal piece to the bottom part so it can stand up on its own and it doesn't require anyone to handle it. Then connecting the 9-volt battery, and it is done. Next part.
In the programming part, we first have to declare the variables, which are going to be V, R, T, and TC. Also have the variables of C1, C2, and C3. These are the ones I told you about just a moment ago, the ones from the logarithm. Then we start. Void setup. 0 begin, normal process, and then pin mode 10, 9, and 8. These are gonna be the ones that are gonna be using as outputs. These are outputs for the LEDs. Okay, so now void loop, and then this is the programming for how we're gonna be converting the voltage in analog 0 and turning it into Celsius. Now we go serial print and temperature, serial print TC, and serial print ln as C. These are the ones that are gonna be seen in the serial monitor. I'm gonna show them to you now. Okay, so these are just to measure it with the computer in the serial monitor. You're not gonna be seeing this when the system is connected to a 9-volt battery. Now, for the thing that actually works is the following. If 55 is less than TC and TC is less than 60, then they'll write 10 as low, 9 as high, and 8 as low. Remember that we connected 9 to the green LED. So that means that whenever TC is between 55 and 60, we're gonna have a green light. Okay? Next, if TC is more than 60, then they'll write 10 as high, 9 as low, and 8 as low. So now the green and the blue are gonna be the ones that are low, and the red is gonna be the high one. So that means it's too hot, more than 60 Celsius, okay? And the rest, if TC is less than 55, then the red one is gonna be low, the green one is gonna be low as well, and the blue one is gonna be the one that's high, meaning it's too cold.
And now it's time to test this device. We can see that when I put the thermistor inside of the teacup, the red light is the one that turns on. This means that it is too hot to drink. If we let some time pass, this red light is gonna turn off, and then the green light is the one that's gonna turn on, meaning that it's safe to drink. If I still let some more time to pass, this green light is gonna turn off and the blue light is the one that's gonna turn on. Now it's too cold and it's reheating. This proves that my system works perfectly with no flaws. So this was my project. I hope you liked my approach and decide to drink tea safely. I'm just kidding. This is really cold now. Bye.